And let me start and continue with the logic as knowledge representation. Now, last time we talked about the important formulas or the important uh, knowledge that is both valid and sound. Okay, now do you still remember the word valid and sound? Now, in representing everyday knowledge, right, representing intelligent systems, so we need some general kind of form about a knowledge, how to represent, how to write down the knowledge, right? So this is important because we cannot write down everything on the world because there are too many, okay? For example, if we describe a particular kind of fruit or particular kind of way of doing things, now if we try to write down all the knowledge, right, without an example or without high level description, it will be too many. Okay, for example, now in the university, we have so many different subjects. We have so many students, right? And then we have so many different things to write down in the computer, for example. Now, if we can have some formula or some high level description, and then introduce the idea of a variable, then the whole thing will be much smaller, much smaller, right? For example, now I can have a lot of rules apply to the high level concept. So for example, so I'm saying that undergraduate students. So this means that those studying the kind of basic degree, okay, 4 years a basic degree. So all these students are I call undergraduate students. Then I can have a lot of rules and knowledge about undergraduate students, right? So if you're an undergraduate student, you need to take 120 credits. So if you're an undergraduate student, you need to spend 4 years, right? If you're an undergraduate student, you need to select a major. So therefore, by inventing, by representing the knowledge in this form, it is very convenient, very useful. Now, similarly, we want to represent knowledge in a form, okay? Now, what kind of form? So we call a valid form. Now, valid form means that these knowledge in day-to-day use, we human being, we are very comfortable. Humans are very comfortable about this form. So what kind of form? For example, if A, then B, right? If B, then C. If C, then E. So this kind of logical form, so we are comfortable. But some of the forms, we are not comfortable. For example, all A are B, right? And then all B are C. And then all C are D. Now, this is comfortable. But however, if you do the opposite, so given that if C equal to D, can we comfortably say that A equal to B? Now, this is the kind of knowledge we are not so comfortable. So if it is not so comfortable, so we don't want it to put into our computer. So therefore, we only put into our computer all those valid forms. So this is the first step. Then the second step is, well, they are only forms, right? We do not know exactly what are the objects you are referring. So what kind of instances? So who is the student you are talking about? Now, for example, if you are saying that all undergraduate students should spend 4 years. Now, this is a general rule. But however, there is an exception. There's an exception student. So that student maybe he is very good at playing basketball, right? He represents the school to play basketball, represent the university to play basketball, and then he won a lot of matches. But however, he may not be able to study in the normal time frame. So he continue playing basketball and also studying. So in this case, it's an exception. His exception, and he may spend 5 years, right, 6 years, or even 7 years in the university because he's a very, very good basketball player. So in this case, so we need to look at what objects you are referring, okay, and then to apply to the forms. So in this case, we call if the form are used correctly, if the form are using all those valid and also true kind of facts, right? So we call it sound and valid. Sound and valid. So in this particular scenario, now we develop 21 sound and valid, okay, knowledge representations. This is the model of our knowledge. So we are quite comfortable that after so many years of studying logic, finally we have 21 very useful, valid forms for us to use. So these are the 21 valid forms we can use. So the next question, of course, is to put into a particular instant, put into a particular object, and to see whether this particular form is true or not. Now, for example, this form P, okay, and Q, okay, therefore P. So this means that P and Q are true. If both of these, okay, both of these are true, so therefore P is true. Now this is the kind of consequence, right? If you think that P and Q are true, right? So the only possible way is both of them are true because N, right? N is the human thinking, okay? So human thinks that N. If you talk about N, right? So therefore both of them should be true. Otherwise, I don't think this is N. I think this is or, right? So this is the kind of human thinking. So in these particular ways, so now we have a lot of possible ways to put into our computer, right? So now we are comfortable. At least we can start our programs development. So we can now use all these. So the first one, now let's go through all these knowledge forms, right? So the first one is if P then Q, okay? So now P is considered true now, P, right? So now P comes to the picture. So now I will conclude Q. Q will be also the result. Now this is the kind of knowledge now I can use to put in the computer, right? And then the second is if P then Q. So now I observe that Q is not true. Q is wrong. So now, therefore, I can give you the answer that P is also not true, okay? So for example, if you study hard, you will pass, okay? So this is the kind of knowledge. If you study hard, you will pass. Now I observe that you did not pass, okay? You did not pass. And then I can conclude that what? You did not study hard. Am I correct? Now, in this kind of reasoning, so now I can have a lot of conclusion. Now, these are the conclusions that the computer can give based on these 21 rules. Okay? So now I have a system that gives us conclusions. I can just follow these rules and then follow the logic Now, this is called logic, right? Follow this logic, then the computer can give me conclusion. Now, this is the first step to build an intelligent system. Understand? Now, let's continue to go through some of these. Now, either P or Q, not P, therefore Q. Either, right? For example, either you go to Chinese restaurant or you go to Japanese restaurant. Either, right? Either you go to Chinese restaurant or you go to Japanese restaurant. Then the fact is not P. You did not go to the Chinese restaurant. So what is the conclusion? The conclusion that you must have gone to the Japanese restaurant. That is very simple. Now the computer, based on these three things, the computer now can give you the conclusion, right? Now the computer, based on that, either Japanese food or Chinese food, but the computer also look at, well, you did not have Chinese food, right? So therefore, the computer will give the conclusion that you have Chinese food. So there's no argument, there's no problem. Very true. Now let's continue. P and Q are true, therefore P is true. Very simple, right? And then P is true, therefore the disjunction P or Q is true. Okay. Now we continue. P or Q or R is the equivalent to P or Q or R. Now, this bracket thing, right? So now, why we have all these rules? Now the best thing is that these are easy for computer to do. Okay. So for us, it may be time consuming to look at all these. But when we put to computer, that would be very easy. The computer very quickly check P or Q. If that P, then not Q. P or not Q, then not P or not Q. Now, that is very easy for computer to do. So this is the first basic idea. Now computer can help us to develop intelligent system. And the programming languages, Prolog, is dependent on these rules. Okay? But of course, not all the rules are used in the Prolog program because of the reason of making the program easier to understand rather than having all these logical kind of description. Okay, so because we want the programming language, the user interface of the language easier, and also there are other implementation considerations. So therefore, the design of the language and the idea behind the language, they have this kind of working together kind of concept. Okay, both of them try to solve the problem. So now, next would be, there are a lot of what we call relationships, right? We want to capture in our computer. Of course, the most fundamental is the relationships, right? Because there are so many happenings in the world, and we want to see whether both the happenings, right? Both happenings, A and B and C and D, because there's so many things happening. So how about their combined effect? So this is the A, combined effect, okay? So now let's see these equivalents. Now, John loves Mary, however, she barely tolerates him. Now, this use of however, actually it is the concept of and. This is the use of English. I think in the use of Chinese, similar. Okay, similar. Similar means that, well, I love you. However, I barely tolerate you. Okay, even I love you, right? However, I don't give you money. Okay, so this is just similar, and. This is the similar idea of an and. So it is raining. Nevertheless, we will go on to a picnic. Okay, so this is just more or less equivalent to and. So the and, the concept of and may not be just using these words. There are other words, there are other English words that also express the meaning of and. The food is not very good, however, it is acceptable. So acceptable meaning that and, right? Okay. Now, for example, after a dinner, right, you ask me, Simon, do you like the dinner? I say, I like it. However, I prefer, or I think the price is very high or very expensive. Okay, so it means the and. Okay, I like the food and the price is too high. Things of that. John is a bit flaky. Still, I like him. This is also and, but still, although not, moreover, not. Now, this is the way, this kind of the English, right? The way to express similar idea of and. Okay, similar idea of and. Now, let's just look at the other knowledge descriptions. Or is more solid than and, because there are not many words that equals to or. So this is the good thing. So in the English, or else, or, okay. So in the English, not many words equivalent to or. Okay, so usually you need to say Reagan or Bush. Either you get out of here, or I will call the police. It is not in here, or else. Or else is equivalent to or. John wants to be a lawyer or a physician. Okay. Now, not of course that there are other words. Okay, synonyms or prefix. Unlucky, right? So if you say the word possible, so impossible, okay? So this is meaning not possible. Right? Impossible, unlucky, okay? So this is equivalent to not. So not, there are a lot of words that can represent the not. Okay, not. Okay, so let's look at the next one. Now the next one is if then. Now if then, in English, there are also quite a number of words that can represent the concept of if then. Okay. Now the first is that, now you should say that if A, then B, right? So this is the kind of usually if A, then B, right? Now if you do not use the then, if you do not use the then, you just use the if, then that becomes B if A. Okay? B if A. Now this is the opposite of saying the same thing. Now there will be dirty rain if the volcanic ash cloud passes over. Now this is the reason. Okay, the volcanic ash cloud passes over. So this is A. If this A happens, then there will be dirty rain. Then there will be dirty rain, okay? So if you don't use the word then, this part is B, this part is A. Now if you use the word then, this part will go to the second part of the English sentence, and then there is the word then here. Okay, so this means that this part is A. If volcanic ash cloud pass over, then the rain, there will be dirty rain. This part is B. Okay, so therefore now you have to be careful when you look at if then. Okay, so usually the A is after the if, the B part is after the then, right? But if you don't use the then part, then this part A is after, okay? So this part B is before the word if. Now this is the English way of saying if then, with the word then or without the word then. Now there's another pair that equivalent to if then. So this pair is provided that. Okay. So provided meaning that if, right? If. Provided that. Okay. So you can go out, provided that you come back at 10. So this is just if, right? Okay. If you come back at 10, then you can go out. This is another English way of saying that, the if concept, if then concept. Okay. And then, of course, if John quit school, he will regret it. So the comma. The comma is equal to then. Okay. So you use a comma. See, if you know something, comma, right? He will do, that will be the consequences. So this comma is equal to the then. So another way of saying that is supposing. Supposing means if, right? Suppose you do this, okay? Comma, right? Something will happen, right? So this is a very sort of very unclear way of saying if then. Okay. So supposing that interest rate remain high, the housing industry will not recover at any time. So actually this comma is then. Supposing is if. Okay. So now when you look at this sentence, now I just cross out this word. I just cross out this comma. Now this part I just add the then here. Now I just add the if here. Now the word, okay, the word will be very easy to understand. If, okay, if interest rate remain high, then the housing industry will not recover anytime soon. Now it is very clear, right? If interest rates remain high, then the housing industry will not recover anytime soon. But in English, there is another way exactly saying the same. Exactly saying the same is that supposing that interest rates remain high, comma, the housing industry will not recover anytime soon. Okay. Now, when you read all these way of expressing if then, right, it is a little bit sort of careful. You need to be a little bit careful. And then in the event that, now there's another equivalent saying, okay, in the event that, okay, so this also if here. So this part is then. So it means that if the volcano explodes, then rescue team will be launched. This is exactly the same. If the volcano explodes, then the rescue team will be launched. But in English, there's another way. In the event that, it means that this will only happen after, this is in the event that after the volcano explodes. Okay. So therefore, if the volcano explodes, then rescue team will be launched. Now this is another way of saying if then. Provided that we have learned it before, provided that is here, then you have comma. Right? You have comma. So remember, all these little things, you have to be very careful about this if-then concept. But anyway, if-then concept is a very common way of representing knowledge. Okay, represent knowledge. And the next one is only if, okay? Now, I think this one only if it's a little bit difficult for Chinese people to understand. Why? Because usually this is because of our culture and our language. Now, we usually will consider the cost first, right? So if something happened, that will lead to something happen, okay? However, the other way around is not a usual way of these Chinese languages expressed kind of causal effects. So only if is usually, now this is interest rate will drop only if there is a recession. So usually this is the A, right? This is the B. If interest rate will drop, then there is a recession. Now this is A and this is B. Okay, so this is the opposite, A then B. Now this is here positive, right? So in the Chinese way of saying, right, this is more natural. This is more natural if A then B, if B then C, if C then D. Now this is the language, the construct, or the reasoning in this Asian kind of culture, right? So we do not reason B only if A only if D only if C. Now after this only if, right, you may have confusion. Okay, now this is the kind of characteristic, right? Characteristic of representing knowledge from two different cultures. From the Western culture, they represent these A-B oppositely, just the opposite, okay? They look at the result first, right? You must have failed the exam, right? Only if you did not study, right? You did not study only if because you do not have enough sleep. Now, all the logic is of the opposite. So when you try to understand how logic is written by different culture, bear in mind these particular characteristics.